Hello everyone, I'm Trina. Today we are going to discuss about coupled circuits, which is a concept in network analysis. You can see my details on the screen. So, introduction to coupled circuits. Coupled circuits involves two or more electrical circuits interconnected through mutual inductance or capacitance. So, we know inductance is from inductor and it is measured in henries, and capacitance is from capacitor, which is measured in farads. So, coupled circuits. What are coupled circuits? These involve two or more electrical circuits. We can see two or more electrical circuits which are interconnected through mutual inductance or capacitance. So, these circuits are fundamental in transformers, filters, and oscillators. These are used in transformers, filters, and oscillators. Understanding their behavior is essential for designing efficient electronic systems. So, coupled circuits and their features are essential for designing efficient electronic systems. So, you can see an example on the screen. So, types of coupling. Magnetic coupling occurs via mutual inductance between inductors. So we know what is mutual inductance. With when current difference is occurred in one coil, induced is produced in another coil. So in the same, magnetic coupling occurs via mutual inductance between two inductors. Capacitive coupling involves the transfer of energy through electric fields between capacitors. So how capacitive coupling occurs means it helps us, or it transfers energy from one capacitor to another capacitor via electric fields. Both types of both types influence how circuits respond to signals and interact with each other. So you can see the types of coupling on the screen. The circuits are shown here. So mutual inductance and coupling coefficient. As we have discussed just now about mutual inductance. Mutual inductance quantifies how effectively one coil induces voltage in another coil. So it quantifies, or it says how effectively one coil induces voltage in another coil. The coupling effect, which is denoted by K, ranges from 0, that means no coupling, to 1, which is said as perfect coupling. These parameters are crucial for analyzing and designing coupled circuits, coupled inductors, and transformers. So, these are essential for designing electronic circuits, as we have discussed. So, mathematical representation of coupled circuits. So, a representation is shown on the screen, as you can see. The coupled circuit equations are derived using Kirchhoff's voltage law. As we know, what is Kirchhoff voltage law? The sum of the algebraic sum of voltages in a circuit is equal to 0. So the coupled circuit equations are derived using Kirchhoff's voltage law and mutual inductance. So for two inductors, the voltage are expressed as V1 is equals to L1 into di1 by dt plus M into di2 by dt, and V2 is equals to L2 into di2 by dt plus M1 into di1 by dt. So these are the expressions which are shown. These equations form the basis for analyzing transient and steady state behaviors. So we know what are the transient behaviors. When an output is sent into a circuit, so the initial conditions are known as transient conditions. So decoupling techniques. Transformation methods like matrix diagonalization simplify coupled equations into independent ones. The use of normal modes helps in understanding the natural frequencies of the system. Decoupling enables easier analysis and better control of the circuit's response. So you can see the image. Analysis of transient response. We have discussed that transient response is nothing but initial conditions. Initial conditions determine the behavior of coupled circuits during switching events. So when we just pass an input to it, so the output shows the initial conditions. Solutions involve solving differential equations with coupled terms. Transient analysis reveals how energy exchanges between coupled elements over time. So as we have said, those are we have said in the definition of coupled circuits. So it shows how energies between coupled elements transfer over the time. So frequency response and resonance. Coupled circuits exhibit phenomena like normal mode splitting and beat frequencies. Resonance occurs when the frequency matches the natural frequencies of the coupled systems. So we know what is resonance. You can see the equations on the screen. So resonance occurs when the frequency circuit matches with natural frequency of coupled system. Analyzing frequency response helps optimize circuit performance for filters and oscillators. So as we have said, these coupled circuits are used in filters and oscillators. So by analyzing the frequency response of these, we can it helps for better performance of these. So applications of coupled circuits. Transformers utilize magnetic coupling for voltage transformation and isolation. As transformers works on the principle of mutual inductance, these are used in coupled circuits. Coupled resonant circuits are used in wireless communication systems. So where signals are used, these coupled resonant circuits are used. Understanding coupling is vital for designing stable oscillators and selective filters. As we have said, understanding these coupled circuits is very important for designing these oscillators and selective filters. So practical considerations and losses. Parasitic effects like resistance and parasitic capacitance affect coupling efficiency. Imperfect coupling can lead to signal attention and distortion. It means disturbance in signals occurs due to imperfect coupling. Proper component selection and circuit layout minimize unwanted coupling effects. So in conclusion, coupled circuits are essential in modern electronics for signal transfer and processing. As we have said, coupled circuits are essential for signal transfers. Mathematical modeling and analyzing techniques facilitate understanding their complex behaviors. Mastery of coupled circuit analysis is critical for designing effective electronic systems and components. As we have said, these electrical components are designed by using these coupled circuits. So that's all for the session. I hope you understand the coupled circuits. Thank you.